Hello everybody, Audio Keller back again with another amp dyno test of a classic Rockford Fosgate amplifier. This time I have a 4-channel amplifier, the Punch 200A4. This amplifier is rated 25 watts into a 4 ohm load of continuous power and 50 watts of continuous power into a 2 ohm load per channel. Fronts and channel backs are all bridged to an 8 ohm load. To check out the output power 4 ohms per channel. Let's start. Continuous output power test with 1 kHz. I apply my input signal and I also go to the clipping point. That's way too much. It looks okay. Take a screenshot. In this case I have 44.4 volts. So I have 43.2 volts and I have an output power measured of 59.8 watts per channel into a 4 ohm load, all 4 channels driven, let's say 60 watts of continuous output power. I start to give full input, full output power, 4 channels, all 4 channels driven with 4 ohms. I have 27.8 amps. I have calculated an efficiency of 63%. Continuous power test with 50 Hz. Clipping. I have some display problems. Try to catch one. But this one looks okay. And you can see here the high frequency distortion. But this is not audible. As you can see, I cannot take this value because it's higher than my main beam. I try to go to manual and read the voltage. I would say it's fair to take this kind of value. So we have 42.3 volts. With a 50 Hz signal, the amplifier still puts out 57.3 watts of continuous output power into a 4 ohm load per channel, all channels driven. Dynamic power test, 1 kHz, 20 cycles. You can see we have a little higher output voltage at the first peak here, and the others are lower than the first. And in this case, the negative is lower than the others. So let's jump to the last one. And take this one here. We have 42.3 volts. That's the same. So we have no increase in dynamic power. Dynamic power, 8 cycles, 1 kHz. With 8 milliseconds I have 60.6 watts on the lowest cycle, and on the first cycle we have 45.6 volts. That means we have a dynamic power at 8 milliseconds from 60.6 watts to 66.6 watts. I'm switching to the 2 ohm tests. All channels are loaded with a 2 ohm load, and I start with 1 kHz continuous output power. Oh, clipping. I take 35.7 volts, around 81 watts of continuous output power per channel into a 2 ohm load. Amplifiers pulling 45.4 amps. With a 2 ohm load for each channel, I calculated an efficiency of 52%. 50 Hz continuous output power. Oops, clipping. Check if I can take this one. Yeah, looks okay. we have 35.7 volts. Please forgive me, I was completely wrong. I measured also with 1 kilohertz and now I measured with 50 hertz and I have an output voltage of 33.3 volts and not 35.4 volts. The amplifier's output power goes down to 71 watts per channel of continuous power into a 2 ohm load with a 50 hertz signal, all 4 channels driven. And now dynamic power test, 20 cycles, 1 kilohertz. First cycle is clean and free of clipping. And we have 38.1 volts. I go down to see there's no clipping. I will jump to the last cycle. That's 36.9 volts. We have in the lowest cycle an output power of 87 watts and the highest cycle has an output power of 93 watts. And dynamic power test with 8 cycles, 1 kilohertz. I have a voltage of 37.2 volts. And I have 39 volts. With 8 cycles we have 88.6 watts on the lowest cycle and 97.5 watts on the highest cycle. Now I jump to the absolute dynamic peak power for 1 millisecond with just 1 cycle. Now I'm catching 1 cycle. And negative looks good, positive is a little bit of clipping visible, so I will reduce my signal input until I can be happy with the signal. I would say it's okay, and I go up and voltage is increasing. So scope says 46.2 and I'm on 43.2. For just 1 millisecond the amplifier is able to put out 119.65 watts into a 2 ohm load, all 4 channels driven, and let's say 120 watts. So we have an increase here. 1 ohm per channel test, dynamic power, 20 cycles. This is the last cycle, by the way. I try to give a little more signal. The amplifier is out of power. I go back. This signal looks good. I have to reduce a little bit more. Looks good again. Okay, looks good. So, stop signal input. I go to my cursor and go to the voltage. I have 26.4 volts. And this one is a little bit higher. We have 27.3 volts. I didn't show it, but all cycles are almost at the same voltage level. At 1 ohm we have a dynamic power from 174 watts to a maximum cycle to 186 watts into a 1 ohm load per channel, all 4 channels driven. Honestly, I did not expect this. I'm testing for a maximum peak power for just 1 millisecond, 1 ohm per channel. You can see signs of clipping here. I'm not going to take this one. Also not taking this one. We reduce a little bit more. The negative one doesn't look too good. Yes, that's okay for me. So we have a higher output voltage. We have 37.2 volts. I had to recheck my calculations 3 times because I can't believe it. The amplifier is able to put out on a 1 ohm load for just 1 millisecond 346 watts. The amplifier is able to put out around 1384 watts with all channels combined together for just 1 millisecond. I did not expect this. The amplifier did not shut off in this test. On a resistive load, this is not a loudspeaker. Let's check out how the amplifier will sound. this video. Even if I did some ridiculous 1 ohm tests on this amplifier, leave a thumb up, write something down to the comment section, and I'm happy to see you on the next dyno video. Thank you very much for watching, guys. Bye bye.